We talk a lot about those big important things for our health,
Right.
like what we eat, how we move.
Yeah.
But today,
Mm-hmm.
we're getting really, really tiny.
Yeah, okay.
We're focusing on a molecule
Interesting.
that most people probably haven't even heard of,
Okay.
but it's absolutely essential.
Got it.
And I'm not exaggerating when I say this.
Oh,
Without this molecule, your arteries would basically just close up instantly.
wow. Okay.
We're talking about nitric oxide,
Yeah.
or NO,
Oh.
and it's time we all understood a little bit more about this incredible little powerhouse.
I like that. A powerhouse.
So that's exactly what we're doing today.
All right.
We are diving deep
Okay.
into nitric oxide.
I'm ready.
We're going to understand what it is,
Mm-hmm.
the many ways it acts in the body,
Yeah.
how it's produced,
Okay.
and most importantly for you,
Right.
how you can actually boost its production.
I like it.
To help us on this deep dive, we have a great visual source today.
Oh, cool.
Really explains NO in a simple way.
Awesome.
Let's get right to it.
Let's do it.
What exactly is this nitric oxide?
Well,
We keep saying NO.
yeah, it's
What is it?
basically just one nitrogen atom
Okay.
hooked up with one oxygen atom.
So simple.
Yeah, very simple molecule.
Right.
But don't let that simplicity fool ya. It's a gas,
Okay.
which gives it some really unique properties.
Yeah.
The source points this out.
Mm-hmm.
NO is highly reactive,
Okay.
and it's very short-lived.
Like, how short are we talking?
Super short.
Okay.
It only exists for about 1/10 of a second,
Wow.
0.1 seconds.
That's it.
That's it.
So it's constantly being made,
Constantly.
broken down, remade.
You got it.
Wow.
That really highlights how much the body needs it, right?
Right. It's like it needs it right now.
Yeah, now.
It can't even store it.
Exactly. It's not something you can just load up on.
Fascinating.
It is.
Now, the source also mentioned that too much NO
Right.
can actually be a bad thing.
Yeah, that's right.
Can you expand on that a little?
Sure. Too much nitric oxide can react with other molecules in the body,
Okay.
like this thing called superoxide radical,
Okay.
and create these things called reactive nitrogen species.
Reactive nitrogen species.
Yeah.
And those are bad.
And they can cause damage.
Okay, so it's all about balance as usual.
Homeostasis.
Right, homeostasis.
Yes.
Which is a theme we see over and over again
All the time.
when we look at all sorts of different systems in the body.
It's true.
Too much of anything is rarely a good thing,
Right.
even things we need.
Yep.
And actually, kind of surprisingly,
Yeah.
the source mentioned that a deficiency in NO
Uh-huh.
is actually pretty common.
That's right.
So it's not just about having too much.
Mm-hmm.
Sometimes we just aren't making enough in the first place.
Exactly.
So that begs the question,
Yeah.
how are we making this stuff?
The good question.
How is our body producing this very fleeting but very important molecule?
Right.
The source outlines two main pathways.
Yep.
Can you walk us through those?
Sure. So the main way your body makes NO,
Okay.
it's called the classical pathway.
Classical.
And we're talking about the majority here.
Okay.
Like 90% of NO production
90%.
happens through this pathway.
Wow.
And this pathway involves these enzymes
Okay.
called nitric oxide syntheses.
Nitric oxide synthesis or not?
NOS.
Okay.
There are actually a bunch of different NOS enzymes,
Okay.
but the source focuses on three main ones.
Three main ones.
Yes.
So, all right, let's break those down one by one then.
Okay, so first up we have NOS1.
NOS1.
It's also called neuronal NS.
Neuronal NS.
Yeah, and that kind of gives away where it is.
Right, I was going to say,
It's found primarily in the brain.
in the brain.
Yep.
Okay.
And it's expressed in neurons.
Okay, makes sense.
So it's involved in all that complex signaling in the brain.
All right, NOS1 in the brain.
That's right.
What about number 2?
Number 2 is NS3,
NS3.
also known as endothelial NS,
Endothelial NS.
often shortened to ENUS.
ENS.
And this one, think of it as like the gatekeeper for healthy blood flow
Okay, I like that.
because it's found in the endothelium.
The what?
Endothelium,
Oh, right.
which is the inner lining of all your blood vessels.
Oh, right.
So ENOS is crucial for cardiovascular health.
Makes sense.
Yeah, keeps those blood vessels functioning properly.
Okay, so we've got NOS1 in the brain's signaling network. We've
Yeah.
got NOS3 keeping our blood vessels healthy.
Right.
What about number 3?
Number 3 is NOS2,
NOS2.
also called inducible NOS or INOS.
INOS.
This one's a little different.
Okay, how so?
It's not constantly active.
Oh,
It's only expressed when it's needed.
interesting.
Like, for example,
Like
during
the-
inflammation.
Okay, so when there's some sort of like injury or something?
Yeah, exactly. Like, let's say you sprain your ankle.
Okay,
It gets all swollen and red.
right.
That's partly due to vasodilation,
Vasodilation.
which means the blood vessels in that area are widening to allow more blood flow.
Makes sense.
And inos is involved in that.
So it's like a temporary boost in NO.
Yeah, it helps bring more blood to the area to aid healing.
All right, so that's our classical pathway.
Yeah.
Driven by these 3 NOS enzymes.
You got it.
Pumping out the vast majority of the NO in our bodies.
Right.
Now, there's another pathway, though, right?
Yeah, there is.
A secondary route.
Yep. The alternative pathway.
Alternative pathway.
It's responsible for about 10% of NO production.
10%. Okay.
And this one's interesting.
Okay. Why is that?
It all starts with nitrates.
Nitrates.
Yeah, and they get converted to nitrites.
Nitrites.
Huh.
And then finally into nitric oxide.
Exactly.
Okay, so nitrates are like the starting material
That's right.
for this alternative pathway.
Yeah.
And what's really cool is that
Yeah.
this process
Mhm.
doesn't need a lot of oxygen,
That's right.
or it can even happen in like a low pH environment.
Yep, it's like a backup system almost.
Interesting.
Right.
And to kick things off,
Mm-hmm.
we actually need bacteria.
We do.
Bacteria are involved.
Yep, they help convert those nitrates into nitrates.
Wow, bacteria.
I know, right?
Often we think of them as bad guys.
Yeah.
But here they are playing a crucial role
Essential.
in this alternative pathway for NO production.
Yeah.
So that means that this pathway is really influenced by what we eat,
It is.
and even potentially by things like supplements.
Exactly.
So while it's not the main producer of NO,
Right.
it's definitely one where we have more direct control.
More influence. Yeah.
Okay.
Mm-hmm.
So we've got these 2 main ways of making it.
Yep.
The classical pathway
Uh-huh.
with those 3 NOS enzymes.
Right.
And then this alternative pathway
Yep.
that relies on bacteria
And nitrates.
and nitrates.
You got it.
Now let's get to the part I think everyone's really waiting for.
Okay.
What does this tiny little molecule actually do?
Right.
What are the effects of NO in the body?
Good question.
The source highlighted 3 main systems where NO plays really important roles.
Yep.
Can you tell us about those?
Sure. So nitric oxide has a ton of effects throughout the body,
Right.
but it's especially important for,
Yep.
the cardiovascular system.
Our heart and blood vessels.
Yep.
Okay.
The nervous system.
Our brain and nerves.
Right.
And our skeletal muscles.
Exactly.
Muscles we use to move.
Uh-huh.
Okay. So those are our 3 big players.
Yep.
Let's start with the cardiovascular system.
All right.
Because as the source really emphasized,
Mm.
this is like crucial.
It's essential.
Why is NO so important for heart health?
Well, remember how NO is a gas?
Yeah.
That means it can move freely into the endothelium.
Okay, that inner lining of our blood vessels.
Exactly.
Right.
Once it's inside the endothelium,
Okay.
NO activates an enzyme.
Another enzyme.
Yep.
Okay, what's this one called?
This one's called guanylate cyclase.
Guanylate cyclase.
Yeah, a bit of a mouthful.
Yeah.
But this enzyme then produces something called cyclic GMP,
Cyclic GMP.
or CGMP.
CGMP.
And CGMP acts like a messenger inside the blood vessel wall.
Okay.
So NO is like delivering a message.
Okay.
And CGMP is the one that actually carries out the instructions.
Got it.
And the main instruction here
Okay.
is to relax
Relax what?
the smooth muscle.
Oh, in the blood vessels.
Yeah.
Okay.
And this relaxation leads to vasodilation,
Vasodilation.
which basically means the blood vessels get wider.
Okay, so wider blood vessels equals better blood flow.
Exactly. More space for the blood to move through.
Right.
And that vasodilation
Mm.
reduces something called peripheral vascular resistance.
Peripheral vascular resistance.
Yep. It's like the resistance the blood encounters as it flows through the vessels.
Okay.
And when that resistance goes down,
Mhm.
blood pressure goes down too.
Oh, so that's how NO helps lower blood pressure.
One of the ways. Yeah.
Makes sense.
And what's really amazing is that there's a baseline level of NO production happening in our arteries all the time. Yep. So our bodies are constantly working to keep those blood vessels relaxed and dilated.
So if we're not producing enough of this NO,
Mm-hmm.
we could be more prone to high blood pressure.
That's right.
Makes
It's
sense.
a really important concept.
Yeah, it shows how this like subtle ongoing process
Right.
can have these really big long-term effects.
Absolutely.
And the benefits for our heart and blood vessels
Uh-huh.
don't stop there, do they?
I don't. No.
What else does NO do?
Well, NO also plays a big role in preventing blood clots.
How so?
It does this by inhibiting platelet adhesion.
Platelet adhesion, what's that?
Platelets are these tiny cells in our blood
Okay.
that help stop bleeding when we get a cut.
Right.
But when they stick together too much,
Well,
they can
right.
form clots.
Right.
And that's not good.
Not good if it's happening in the wrong place,
Exactly.
like inside a blood vessel.
Right, which is called thrombosis.
Thrombosis, okay.
And NO helps prevent that by keeping those platelets from getting too sticky.
So it's like a natural blood thinner
In a way, yeah.
Interesting.
And there's even more.
Okay, bring it on.
NO also helps to decrease the growth of smooth muscle cells inside the artery walls.
Okay.
And this is important for preventing the buildup of atherosclerotic plaques.
Oh, plaques.
Yep. You know, those fatty deposits that can clog our arteries?
Right.
So NO is basically providing this ongoing protection against heart disease.
Wow, that's pretty amazing.
It is.
So just from a cardiovascular standpoint alone, we're seeing that NO is essential
It's vital.
for healthy blood flow,
Yep.
healthy blood pressure, preventing clots,
Right.
and protecting against the development of plaque.
It's a busy little molecule.
It is a busy little molecule.
We're in a lot of good work.
All right.
Yeah,
Now,
yeah.
the source also described NO's effects in the nervous system
Right.
as being like super interesting.
I think it is.
So what's so special about NO in the brain and nerves?
Well, in the nervous system, NO acts as what we call an atypical neurotransmitter.
Atypical neurotransmitter.
Yeah.
What makes it atypical?
Unlike most neurotransmitters,
Okay.
NO doesn't bind to a specific receptor
Oh,
on the receiving cell.
interesting.
Remember, it's a gas,
Right.
so it can just diffuse freely across cell membranes.
So it's less like a key fitting into a lock
Yeah.
and more like just a
Yep,
general broadcast.
more like a general broadcast.
Okay.
This type of signaling is called paracrine signaling.
Paracrine.
Yeah, meaning it acts locally.
Okay.
So in the brain, specifically within neurons, NO is involved in something called synaptic plasticity.
Synaptic plasticity. That sounds complex.
It is, but it's basically the ability of our synapses.
Okay, synapses.
Those connections between brain cells
Right.
to strengthen or weaken over time
Oh, interesting.
based on our experiences.
So like when we learn something new,
Exactly.
the connections between certain neurons
Yep,
get stronger.
that's right.
And that's how we remember things.
Exactly. It's called long-term potentiation, or LTP.
LTP.
And it happens in a part of the brain called the hippocampus.
Hippocampus.
Yeah, which is really important for memory formation.
So good NO levels are essential for learning and memory.
They are.
Wow. I never would have thought
It's pretty amazing.
that this simple gas molecule
Yeah.
would be so crucial
Right.
to how we learn and remember.
It's amazing what our bodies can do with such simple building blocks.
Absolutely. And its influence
Uh-huh.
doesn't stop in the brain, does it?
No, it doesn't.
Tell me about NO and the rest of the nervous system.
All right, so in the peripheral nervous system,
Okay.
NO helps to relax smooth muscle.
Smooth muscle. Okay.
A good example of this
Yeah.
is in our digestive system,
Okay.
in the enteric nervous system,
Enteric. Okay.
which basically controls our gut.
Right.
NO helps regulate something called peristalsis,
Peristalsis.
which is the wave-like muscle contractions
Okay.
that move food through our intestines.
Right. Right. So it helps things keep moving.
Exactly, keeps everything flowing smoothly.
Okay. So another essential role for NO.
Yep.
But like in the cardiovascular system,
Mm-hmm.
we have to be careful
We do.
not to have too much
Right.
NO in the nervous system.
Yeah.
Can cause problems too.
That's right. It can lead to something called nitrosative stress.
Nitrosative stress.
Yeah, which is kind of similar to oxidative stress.
Oxidative stress.
Uh-huh.
We hear about that a lot.
We do.
It basically means
Yeah.
that there's an imbalance
Right.
between these things called free radicals
Yep.
and antioxidants.
Uh-huh.
And in this case,
Yeah,
it's not free radicals, it's these reactive nitrogen species.
exactly. Reactive nitrogen species are like the free radicals of the nitrogen world.
Okay, so they can cause damage too.
They can.
All right, so again, it's all about balance.
Balance is key.
Not too little, not too much.
You got it.
Okay, let's move on to our third big system,
Right?
skeletal muscle.
Okay.
This is probably the one a lot of our listeners are really interested in because it relates to,
Yeah,
physical performance.
exactly.
How does NO impact our muscles?
Well, in skeletal muscle,
Okay,
NO is a powerful vasodilator.
there's that word again, vasodilation.
Yep, meaning it increases blood flow to the muscles.
Makes sense.
And that increased blood flow
Yeah,
delivers more oxygen
more oxygen.
and nutrients,
Okay,
which are crucial during exercise.
right, got to fuel those muscles.
Exact.
And it's not just about bringing the good stuff in.
Right.
NO also helps to clear out the waste products,
It does.
like carbon dioxide,
Yep.
lactate,
Uh-huh.
and hydrogen ions,
You got it.
which can build up and hinder performance.
They can really make you feel that burn.
Right, so it's like NO is helping to both fuel the muscles
Mm-hmm.
and take out the trash.
Exactly like a two-way street.
That's a great analogy.
I like it.
And there's actually an even cooler aspect to this.
Oh, there is?
NO has been shown to reduce the oxygen cost of exercise.
That's right.
What does that mean exactly?
It means that for the same amount of work,
Okay.
your muscles need less oxygen,
Wow.
and your body becomes more efficient.
That's amazing.
It is.
It's like getting better gas mileage.
Kind of, yeah.
You can go farther on the same amount of fuel.
Exactly.
Incredible. And it also promotes something called mitochondrial adaptations.
It does.
Mitochondrial, what was it?
Adaptations. Adaptations, okay.
Which basically means it helps your muscle cells create more mitochondria.
More mitochondria. Now, remind me, what are mitochondria again?
Oh, they're like the powerhouses of the cell.
Right, the energy factories.
Exactly. They produce the energy our cells need to function.
So NO is helping our muscles produce more energy.
It is.
Wow.
Pretty cool, huh?
It really is.
And on top of all that, the enhanced blood flow from NO also helps with post-exercise recovery.
Okay, how so?
By delivering all those building blocks for repair.
Okay, like amino acids.
Yep, amino acids.
And fuel sources like glucose and fatty acids.
So it's not just about performance during exercise.
Nope.
It's also about recovering faster afterwards.
Exactly.
All right, so we've covered what NO is, how it's made,
Uh-huh.
and all the amazing things it does in the body.
Yeah.
Now for the big question.
Okay.
How can we actually boost our NO levels?
Right.
What can we do?
That's the million-dollar question.
It is.
Luckily, the source gives us 3 main strategies.
Okay, I like when they're actionable things.
Right.
Lay them on me.
All right, so the first strategy is to supplement with certain amino acids.
Amino acids, okay.
Specifically, citrulline and arginine.
Citrulline and arginine, okay.
These are considered semi-essential amino acids.
Semi-essential, what does that mean?
It means that our bodies can produce them,
Okay.
but sometimes we might need a little extra from our diet or supplements.
Okay.
And these amino acids can act as precursors for NO production.
Precursors, so like building blocks.
Exactly.
Now, I remember the source said that arginine isn't always the best way to go.
That's right.
Why is that?
Well, arginine has lower bioavailability.
Bioavailability.
Yeah, meaning that a lot of it gets broken down in the liver
Okay.
before it can even reach the bloodstream.
So we don't absorb it as well.
Exactly.
Right.
But citrulline,
Citrulline?
yeah, that's a different story.
I
So
see.
citrulline has much better bioavailability.
Okay.
It gets absorbed more efficiently.
Got it.
And then it travels to the kidneys.
The kidneys.
Where it's converted into arginine.
So it's like a roundabout way of getting more arginine.
Kind of, yeah.
And then that arginine can be used to make NO.
Exactly.
Now, I thought this was interesting.
Yeah.
The source mentioned that when arginine is converted to NO, it also produces citrulline
It does.
as a byproduct.
Yeah.
So it's like this cycle.
It is like this little recycling loop.
That's pretty cool.
Yeah, our bodies are really efficient.
They are.
Now, even though arginine might not be the best for boosting NO,
Okay.
it can still be helpful for some things.
Like what?
Like erectile dysfunction, for example.
Oh,
There's some evidence that arginine supplementation can help with that.
interesting.
But for overall NO production,
Mm-hmm.
citrulline is usually the better choice.
Makes sense.
So that's strategy number 1.
Amino acids.
Yep.
What's number 2?
Strategy number 2 is all about antioxidants.
Antioxidants. Okay.
Now, antioxidants don't directly increase NO production,
Okay.
but they can protect the NO that's already there
How so?
by reducing its breakdown. So it's like they're helping NO last longer.
Got it.
There are lots of different antioxidants.
Like what?
Well, there are polyphenols,
Polyphenols.
which you find in things like cocoa,
Cocoa tea.
coffee. Those are all good sources of polyphenols.
And then there are isothiocyanates,
Isothiocyanate,
which are found in
garlic.
garlic. Okay.
And then there's lycopene.
Right.
That gives tomatoes and watermelon their red color.
Oh, right.
And all of these antioxidants can help to reduce oxidative stress, which can damage NO.
So it's more about preserving the NO
Right.
than actually making more of it.
Exactly.
Okay, so boost antioxidants
Yeah.
to protect NO.
That's strategy number 2.
All right, what's our third and final strategy?
Strategy number 3 takes us back to that alternative pathway.
Oh, the nitrate pathway.
Exactly.
Okay.
And this one's all about increasing your nitrate intake.
Nitrate intake?
Yep.
Through diet or supplements.
Right.
And when we talk about dietary nitrates,
Mm-hmm.
the first thing that comes to mind
Yeah.
is beetroot.
Beetroot, it's the classic.
Yeah.
It's been studied a ton,
Right.
and it's a great source of nitrates.
Yeah, you see a lot of athletes using beetroot juice
You do.
to boost their nitrate levels.
Yeah.
But beetroot isn't the only option, is it?
No, it's not.
What else can we eat?
Well, other leafy green vegetables are good too.
Leafy greens,
Like arugula,
arugula,
kale,
kale,
lettuce.
spinach.
Right.
Okay, so all those good greens
Yeah.
packing in those nitrates.
Yeah, they are.
Now, one thing to keep in mind,
Yeah.
the nitrate content of these vegetables
Mm-hmm.
can vary quite a bit,
It can.
depending on things like soil quality.
That's right.
So you might not always be getting the same amount
Exact.
from the same serving of vegetables.
Not always consistent.
And for athletes
Mm-hmm.
who are really trying to
Yeah.
maximize their performance,
Right.
it can be tough
They can be.
to get enough nitrates from diet alone.
Exactly. Imagine trying to eat enough beetroot
Oh my God.
to get the amount you need.
Right.
That's a lot of beetroot.
It is.
And it might displace other important foods in your diet.
Right. You can't just eat beetroot all day.
Exactly.
So that's where nitrate supplements come in.
They do.
They provide a more consistent dose.
Yep.
And they can be helpful for both performance enhancement
Right.
and potentially even for cardiovascular health.
And even erectile dysfunction.
Oh, yeah, right. We talked about that.
Yeah.
Interesting. Now, the source did mention a pretty important caution
Yeah.
regarding nitrate supplementation.
Yeah, this is important.
What is it?
High doses of nitrates
Okay.
can lower blood pressure.
They can.
Yep.
Okay, so for people who already have low blood pressure,
Right. Or for people taking medication for high blood pressure.
right, those antihypertensive
That
medications,
could be a problem.
it could cause their blood pressure to drop too low,
Right.
which could lead to things like dizziness,
Okay.
headaches.
Yeah, not good.
Not good.
So it's definitely something to be careful with.
Absolutely talk to your doctor
Right.
before starting any new supplements.
Always good advice.
Always.
And there was also that interesting tidbit
Oh, yeah.
about antibacterial mouthwash.
Right.
What was that all about?
So remember how the alternative pathway
Yeah.
relies on bacteria in the mouth?
Right. To convert nitrates to nitrate.
Exactly.
Okay.
Well, antibacterial mouthwash
Right.
kills those bacteria.
Oh, so it can actually reduce NO production.
Wow.
Yeah, who knew?
I know.
Your mouthwash could be messing with your NO.
Right.
It's a good reminder that everything in the body is connected.
It is. It really is.
You know, even seemingly unrelated things.
Right, like mouthwash and NO.
Exactly.
So much complexity.
There is.
Okay, well, this has been a really fascinating deep dive
It has.
into this tiny but mighty molecule.
Tiny but mighty.
I love that.